Hi, I'm Krithika, a grade 11 student at Beamsville District Secondary School. In this video, I'll be talking about spectroscopy, which is the dispersion of an object's light into its component colors or energies. When an excited atom gains energy, the electrons can move into a farther orbit with a higher energy level. When the electrons jump back down again, they emit a photon. Each jump corresponds to a particular wavelength of light. When the electrons fall to lower energy levels, they give off light in the form of a spectrum. Depending on how frequent certain electron transitions are occurring, they'll appear brighter on the spectrum. Each element has its own unique atomic emission spectrum, which can help identify them. This is useful for scientists when determining the composition of far-off stars. In this video, I'll be performing an experiment exploring this concept. The purpose will be to identify an unknown gas and determine the energy of 3 prominent electron transitions. The materials being used are a spectral tube power supply, the gases in tubes hydrogen, neon, argon, and helium, the unknown gas, and a spectroscope. The first tube, hydrogen, was placed in the power supply. The spectrum was observed through the spectroscope, which calculates the amount of light absorbed or transmitted at each wavelength, and 3 of the brightest lines measurements were recorded. Here's an image of hydrogen's atomic spectrum. The values found were as follows, and this process was repeated for helium, neon, and argon. The unknown gas was then placed in the power supply. Knowing that it has to be the same as one of the first 4 gases, it can be predicted by the color that the gas is helium, but this can be confirmed by the measurements recorded. There is some error involved, however, as the accepted values of helium are different, causing a percent difference of about 5%. The measurements of helium and the unknown gas are almost identical, leading to the conclusion that the unknown gas is helium. The energy of the transitions recorded will be calculated using the equation energy is equal to Planck's constant h times the speed of light c divided by the measurement made in the experiment lambda. The first measurement will be used as an example, 4400 angstroms. Multiplying the value found by 6.242 times 10 to the power of 18 gives us the answer in electron volts. In conclusion, the values of energy of the transitions in the helium gas are 2.8, 2.5, and 2.0 electron volts. I believe this internship is a great opportunity for me to learn more and gain some experience in my field of interest. I love physics because it can make a person see the things that they encounter every day in a whole new light. Without it, there would be so much about the world that we would not know. When partnered with engineering, the two throw the door wide open for advancements in technology. Engineering has created the world that we live in, with the phones in our pockets to the most advanced medical technology. I always face every task that I take on with the utmost dedication. The field of engineering physics is ever-changing, and I hope that one day I will be able to make a contribution towards that change, which is why I believe I'm the perfect candidate for this internship. Thank you for watching my video, and I hope you enjoyed it.